It is time for a project to make, rather surprisingly, an LED lamp, but this one is really neat. Now, I want to say at the beginning that this does use a 3D printed component as the end for the test tube that we're going to use, which you can get off eBay. The test tube off eBay. You print this yourself, but you do not need a 3D printer because you can also just use a cork or a rubber bung or whatever you can get that goes in the end. That could be hot melt glue, anything at all. So this project isn't exclusively to people with 3D printers. So here's a little story behind it. I decided to make a sort of low voltage lamp because many of the lamps I've made in the past have been 240 volt or 120 volt, and that just makes it a bit more dangerous for people just getting into electronics and stuff like that. So this one is actually going to be powered by USB. And I got a choice here of a pink or a blue cable. I shall make that decision later. But it's just a standard charging cable, dollar store type charging cable. These probably came from Poundland or One Below in the UK. And the idea was with this one to have a cable inlet, this is just far too big, but that's okay. That has since been adjusted. And then an adapter, slight taper up so you could glue it into the end of the tube. And that would let you terminate the cable and the resistors could be inside if needs be. And then you'd have LEDs in here. For the LEDs, we're just going to use generic, cheap eBay LEDs, the copper wire strings. I was going to cut that, that's not the bit I want to cut. I thought that was a tie. Wow, that almost ruined the project. But what we have here, we've got this rather twee set from eBay, which has a little double button cell holder that is very, very intermittent. You can see them sort of flickering there as it's moved and they cut in and out. It's crap, but that's okay. What we really wanted was just these. You can also get these with a battery pack, and you can get strings of like 10 meters with 100 LEDs. Just whatever you want. What we're going to do here, we're just going to cut it down to size. So this string is actually, there's something interesting I've just spotted that really is interesting. I noticed that these LEDs were closer together than where it terminates here. You can see where they've actually buffed through the insulation. So does that mean this is going to short these out if these wires touch here? Let's test that. Is it buffed right through? I'm not sure if I'm getting a contact there. Yes, it is. So they've buffed it in readiness for another LED, but not put one on. Maybe this is just reject strings, but it doesn't really matter in this case. All you want is a section of LEDs, and we're probably only going to use 20, so let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And this, it turns out, is a 30 LED string, but to be honest, we don't need that many. So I'm going to cut this down to just 20 LEDs. I could try squeezing them all in. Will I try squeezing them in? That's going to make it so much harder. Let's not do that because it's bad enough fitting 20 LEDs in here. But then the temptation is there to be greedy. I shall be greedy. We'll try and fit the whole lot into this tube. It's going to be a tight fit though. So the first thing I'm going to do here is, the first thing I should do is explain that if you've got a 3D printer, here's how to print these components, and I'll show you what happened because something went wrong. I made the prototype up and I thought that's pretty good, but I realised that people will get tubes off eBay, there'll be different sizes. So I wrote a script for OpenSCAD, and the OpenSCAD script has a variable. If you download this script, you can actually go down to the description down below. You can copy and paste this script. There's two sections down below. There's a section for making a little test adapter. It's a wee short section of script. I shall make sure they're well documented down below what they are. But then there's the main one. And you've got one variable here, and it's called diameter. And it says diameter equal 16, and then there's a semicolon. You can change that number in here to anything you like between 10 up to about 30 or bigger, and it will automatically scale everything to match. It's very versatile. So that's down below. If you've never used OpenSCAD before, you don't have to understand how to work it. All you do is copy the section, download and open OpenSCAD. It's free. It's an open source system. Copy and paste that text into the little window at the side. And then there's a little double arrow down here. Well, it can all be done up here. There's a little cube with a sort of double arrow in it. That lets you see what it's going to look like. If you then press the one with the hourglass in it, that will then make your process and make the whole file, and then you press STL and it will save that file, that customized file just for you, for whatever tuber you used. This came from eBay. It's 18mm outside diameter, roughly 16 inside diameter, which is the bit you want, and it's about 200mm long. You can shop about because some people sell these in bulk and other ones are just selling them one at a time at great expense. So initially I used a caliper to measure this, like this, 16.2 roughly. And let's measure that properly. Yeah, about just under 16. And then I played safe and made a size that was a bit smaller. And I have to say, it ended up, I made a couple of versions, a really thick one, that's a fairly close fit, and a thinner one. And the first version I made was a bit loose, and I thought, maybe I can tighten that up. Maybe I can put some recesses in it and put an O-ring on. And the O-ring, if I use a couple of O-rings along the length, there was going to be one, say, roughly about there, and then one there. I thought it would then squeeze in and just sort of be a nice friction fit. In reality, it broke the test tube. Yeah, so you don't want to apply too much pressure. Don't force anything into the test tubes. It's very easy to break them. So, having done that, it worked out a bit loose, and I thought I really want to be able to check this out for size. So there is another script down below. It's the first script. And once again, it's got this diameter variable. Things worth noting, when you change that number, watch you don't remove the equal on the left-hand side or the semicolon on the right-hand side. They're part of the code, they're needed. So just change that number, and once you rebuild it, you'll get this. In this case, it's a little test sizer. The front section is 0.5 millimeter smaller than the size you entered in. The mid section is the size you entered in, and the back section is 0.5 millimeter wider. And the front one is loose. The middle one is a decent fit. In this case, it was 16. The back one is not going to go in. Don't use excessive force. You will break the test tube. So in this instance, the sizer has shown that the size entered is what's going to work, 16. So now we go to the 3D printer and we print that. Now it's printed, we're ready to begin. I just want to say that I used calipers earlier on. Just using a ruler held inside is absolutely fine too if you've not got a set of digital calipers. Digital calipers are one of my most used tools here for measuring because they're just superb and they're cheap. They're just a very, very clever and mass-produced device. They're fantastic. I'll just pop those out of harm's way. So here it is, it's got a little raft on the bottom of it. We can cut that off. Well, we can just snap it off by getting a pair of snips and just applying a bit of pressure, and it comes off neatly. If there's a rough edge in the bottom left after that, note that the raft is just something that my Cetus 2 3D printer by Tier Time does. It's, I don't know what other printers do in that sort of situation. It's just, it makes this little thing that gives it good grip. It really squishes the plastic onto the base, the build platform, which isn't heated, by the way. And then it just makes it very easy to just snap that off. And the reason I put the smaller end at the end down the way, it takes advantage of that raft. I don't know. Let me know if you build one of these, how you got on. Now we have to choose a lead, and it kind of, you know, pink looks like it should be the right colour for this pink thing. For those of you wondering why pink keeps appearing in this channel, it's because a long time ago, I had a bit of an incident when I had one of the first sets of pink LED fairlights. I'm just cutting the big plug on this end, small plug on this end, I'm cutting that off. We just want open tails here. I had a bit of an incident when I was playing about with one of the first sets of pink LED fairlights, and I plugged them into a cheap power supply, and it detonated. It went bang. And it left a big skid mark, a scorch mark of the outside of the seam of the case on my hand, which was very exciting. It was funny. After that stunned pause of what the heck just happened, I just burst out laughing because the whole concept of some Barbie pink thing just detonating forcibly was just so funny. So this is covered in a fabric outer. It seems to be a common style. It's just cosmetic. It's the same white plastic inside. And then I'm going to nibble. You can actually pull this sleeving back. It's like that. Maybe I should have done that. That might have been easier. Maybe I should not have done what I've just done. Oh, rightio, it's not going back. That's fine. We shall improvise. I shall use my more electrician-y type snips of this because they're maybe slightly better at nibbling than the fine ones. Let me just rake around through my stuff till I find it. What I'm going to do is I'm going to gently nibble around the plastic here. Another thing I could have done is actually use a proper wire stripper for this, but I'm not. Maybe I should zoom down this so you guys can actually see what I'm up to. At this point in time, I shall also stick the soldering iron on because that's useful because we're going to be doing some soldering, but it's not much. So I'm nibbling around that, and then I'm going to strip off the outer sheath. We've got a red, black, white and green wire in here. Sometimes it's a grey and pink because they just cut back on the colorant just because, well, just because they do. We don't need the green and white one. And what we're going to do is we're going to strip the red and black. Now, the red I'm going to cut quite short, and I'm going to strip it off. The black I'm going to leave a bit longer. This is just so the solder connections, these connections are not next to each other. We will be sleeving them though afterwards. The other things you'll need for this project, incidentally, are a 22 ohm resistor and a bit of sleeving if you got it, heat shrink sleeving, but you can also use tape. I'm just going to put some solder in these, if the solder iron's up to temperature, which yeah it is. A little bit of solder in these leads. I cut them very short, but as soon as I put solder on, they'll sort of, the insulation will melt back. That's just what happens. Right, first things first, before we progress any further, let's bring a meter in, set it round to voltage and double check the polarity. I've said this before, I'll say it again. You have to check the polarity of these USB leads. Sometimes black is not negative and red is not positive. Is it going to display 5 volts? It's displaying 2.9. That's exciting. Okay, so that power supply is one of these ones that needs to wake up probably. Rightio, but the polarity is correct. It's woken up. We have our polarity. Rightio, so the polarity is correct. We can unplug that again. You can adjust the value of the resistor. If you've got one of these power supplies that won't wake up, won't stay awake unless it's above about 100 milliamps, you can lower the value of the resistor slightly to about 18 ohms or so. Because what we're working on here is the LEDs are going to be about 3 volts across the string. The USB supplies 5 volts. We have to drop 2 volts. So to get the current that we want of about 100 milliamps, that's that. The resistor will be 2 volts to drop from the 5 volts to give us the 3 volts, divided by the current we want, which is 100 milliamp, which works out about 22 ohms. Right, what we're going to do now, we have this string of LEDs. I'm going to crop the string, crop that little battery pack off and tuck it out the way. And I'm going to flow some solder onto the end of these. Now, these are insulated with enamel, these wires. So, depending on the type, some of them are quite receptive to just melting that back with a bit of heat. Let's see if this one does it or not. Yeah, it looks as though it's taking the solder at the end. That's good. And now we have to work out which is positive and which is negative. That is actually fairly easy. You get one of the batteries out of that battery pack and you just dab the lithium cell and you just dab the wires across either side. Nothing lit. I put it across this way. They're glowing. That means this one on the positive connection was the positive. Rightio, that was also a bit of a flat battery. Maybe I should have a purge of shit batteries soon. I'm going to put a bit of red in that with a Sharpie. The Sharpie will also be used to shape the wire later on. Now, the positive lead here, I'm going to put the resistor on it. So I'm going to get these LEDs out the way. I'm going to put them over my shoulder because otherwise they're just going to drop on the floor and be lost forever. I have my 22 ohm resistor here. I'm going to crop the lead short to about, maybe about 1/8 of an inch, 3 millimeters. I'm going to tin it with some solder. like this. Put a decent blob on it because I'm going to flow it onto, I'll tell you what, here's a great idea. Here is a great idea. Let's actually feed it in through here first. Oh, I should have done that before I even stripped that cover off. That's all right, it's saved. Something worth mentioning, the cable grip we're going to be using here, and I can actually apply that now. It's just a cable tie. But there's a bit of sweet technology involved in the design here. I'm putting this cable tie around. I'm going to try and move that that pink sort of material. I'm going to try and get it a wee bit further up. That's better. A little bit of a design that I put into this was a taper inside that. The reason it's tapered at the base is because if you put a cable tie around, you pull it snug and then you crop it off and you pull it into the base. When it goes into the base, as you pull it down, it kinks it over to the side and it grips it really tight. It actually locks it into the base. So that's a really good strain relief. But anyway, now I've saved the project by not soldering things on before I'd put it through this. Let's solder the resistor onto the positive lead. It could go on the negative lead. If you're running at very high current, you can also use a resistor on both, just to spread the dissipation. That is a resistor soldered on. The two wires have ended up roughly the same height. This isn't necessarily a great thing, but it doesn't really matter, to be honest. I have heat shrink sleeving. Let's cut a bit of heat shrink sleeving now. So now I bring in my lights, which are pre-tinned, and I'm going to add a bit of solder to both these connections. On the positive, which to cover the resistor, I'm going to slide that bit of heat shrink over now before I solder it on. That's another thing you can screw up by getting it in the wrong sequence. But this is one of these things that, you know, only by doing it accidentally, I mean, like, even the oldest veterans in the audio industry will, or the lighting or audio industry, will still put connectors together and forget to put an end cap on the cover. And then it's really annoying when you find out you've done that afterwards. So now I'm going to solder the positive connection onto the resistor. I'm just shaping that so it's nice and square. Reflow. Excellent. Hold it there for a second for it to cool down and cure the solder. Then I might as well just actually get the heat gun and shrink that down over that. Which I shall do, and this will stop anything else shorting out to it. Heat gun, incidentally, is part of a soldering station, a cheapy Chinese station called a Yahoo 87860D. I don't know if they still do that particular model. There's lots of versions. It's very useful, mainly for heat shrink, but also useful for reflow of surface mount components. I didn't really get it with that in mind. I got it with the heat shrink in mind, but as time goes on, I find myself using more and more surface mount components. There's not really much choice. Everything is going surface mount these days. So now let's join the negative lead to the USB negative lead. And then we can test this and see if the LEDs are going to light. That looks okay. It's not pretty, but it's okay. And I'm going to bring the LEDs on, and I'm going to plug this into the USB power supply, and the LEDs have all lit perfect. Now comes the tricky bit. I'm going to zoom out for this because it's going to get a bit sort of messy. I'm going to get, say for instance, this end, and I'm going to start wrapping it quite tightly around the Sharpie, like this. And it's a lot. I have to say I could seriously regret deciding to go out of just sheer greed, by the way, with the 30 LEDs. But you know what? If it's worth doing with excess. So I'll just keep winding this round. How many have I got on so far? I think about halfway there already. I'll just dangle that down, let it all untangle itself. Bear with me a moment as I destroy the place. We'll slide this up here. We'll just slide it under that clip. just to make space and smoosh it all up. This could be quite time consuming, or it might just absolutely fly in. Hopefully, depending on the spacing of the LEDs, they'll form a random spiral as they go in. So let's keep just winding this round until I reach the end. Oh, hurry up, end, where are you? The end is nigh, it's actually approaching. I've just whacked the camera, my apologies. We're almost there. Looks a bit messy. Now you can get the copper wire LEDs or you can get the silver wire. I tend to recommend the silver because it's kind of more reflective to all colours. It gives you more colour choice. Okie dokie. So now we pull this off and we've got a big spring of LEDs. And the tip one I'll just fold into the middle. And now comes the tricky bit. It's like trying to push a slinky upstairs. We want to try getting these into the test tube. So I shall just keep pushing it in. By rotating the test tube, it will actually try and tighten the spring in itself. And when you tighten the spring, it makes it thinner. This could all go horribly wrong still. It is kind of all going horribly wrong. Excellent. That's what we want. It's real life. Oh, I really have tangled that quite badly. Not to worry. We shall just make it up as we go along. I might even use a pointy stick and poke it in. Maybe I should have used something narrower than that. Maybe I should just not have been so greedy. Do I have anything I can poke this in with? Not really. I can't really see anything close to hand. This is rapidly going wrong, but I'm not going to stop. I'm just going to keep fighting with this because this is, as I say, real life. This is what can happen with this project. Oh, yeah, seriously. Regretting it so much. Let's pull that back out. Yeah, that wasn't working too well, but that's okay. It's fine. I'll recover it. If anything, I would say maybe this coil, maybe I should have wound it around a thinner former like a pencil. But you know what? I have no regrets. Let's have another go. It helps if you actually take it off. I'll take it off camera and do this. You actually give it a swipe like that. It makes them ping down inside. I'm just going to try that right now. They moved. Not a lot, but they did move. This is because I've been too greedy. You see, that's the indecision earlier on about using just 20 LEDs. That would probably be a lot better, but not to worry. I've started, so I'll finish. I will go on so far, and if I don't end up with results, I shall just momentarily stop so that you don't have the torturous experience of seeing me desperately trying to recover the situation. Oh no. I'll just try giving it another ping. Oh, that's it. It shot up to the end. That's better. And just keep stuffing the LEDs in. God, there are so many LEDs. I put far too many in. That's just greed. That's what happens. Yeah. Okay. Yeah, very much regretting this. Here's how you make a shit light by just being greedy. Let's try just shoving things up there. Anyway, make sure you don't do yours as badly as I've just done this one. Yeah, it's going in. I don't give a shit. It's just, it's getting rammed in. Right, tell you what, I'm going to give that a shake again. Oh, there they go. They spread out. And now we slide the end cap up. And this is where you can glue it in, but the choice of glue will depend on whether you intend to re-enter later on and redo this. So that's it. It's a nice end termination like that. Let's try it out, shall we? By plugging it into a USB power supply and taking the exposure off and then turn the light off. Oh, that is... Actually, it's not too bad. I'm going to try and lock the exposure... Let's see, I'll just try... no, I'm not going to be able to do this. God. Right, anyway, what you're seeing here is pretty much what you're going to get. It is pretty bright. I've made one of these before, the prototype, and I turned all the lights off in the house, and just running off the USB power supply at about 0.5 amp, this was amply bright, and it produces a nice pattern, as you can see, because all the bits of wire. So you can do this with any colour of lights you like, and if you change your mind later on, you could even use a little connector down here with a resistor, and you could just open it and change LEDs. Or, given how cheap test tubes are, given that you can effectively use a rubber cork or a rubber bung or a cork in the end and just drill a hole through the middle of it for your USB lead, there is always the option of just making lots of them. Things worthy of note about the rubber bung: if you try drilling a hole through a rubber bung or a cork, be prepared for it to snatch suddenly in your fingers as you're drilling it. It can be tricky. But there we go. I might put a daub of hot melt glue in the end here, just a wee tiny bit, and then just push it in to hold this together. But actually, I would say that was a success. I would say that was a very good result. So there we go. The light is about to come back. Watch your eyes. And that's it. So all the files for printing this yourself, the test tubes, including this broken one here, are available on eBay. You'll find a whole selection of things. It doesn't have to be a test tube, it could be a bottle, because all you need is the inside diameter to be somewhere between 10 to about 30 millimeters, and you'll be able to make one of these that goes into it. And then just cheap USB leads chopped up, that 22 ohm or 18 ohm resistor, and the world is your oyster. You can use 100 LEDs off the same thing and it will still run at low power, or you can use lower value resistors, a couple of them, and just actually boost the current up a little bit. Say for instance a couple of 5 ohm resistors. So let's see, what's the closest to 5 ohm? 5.6 ohm resistors would work. A couple of those, one in the positive, one in the negative, bit of sleeving, and you could run quite a lot of LEDs and make bottles into lights as well. So I'd say that's a pretty good result, even despite my best efforts for it not to be. But there we go. The files are down in the description down below, so you can play about this yourself and enjoy making your light.